Okay, for the last detection test, Durban Watson d-test. Okay, so I want to first talk about this concept called autocorrelation coefficient. So you will run the regressions. Residuals at time t is a function of residuals lagged by one period. And when you run this regression, you don't include a constant. Remember, this is called regression through the origin, which you learned from ECO311. So this is how the regression looks like. Residuals, let's say at time t equals b2 hat, the slope parameter, times residuals of the previous period. And constant b1 hat does not feature. And this B2 hat, the slope parameter, actually gives you the autocorrelation coefficient, rho hat. Then it means the extent of relationship between the residuals. Remember, residuals are the proxy of error terms. So this is an example. From this regression, we see the autocorrelation coefficient is 0.222. Then we say the positive, then we say positive autocorrelation, and it is quite a weak positive autocorrelation. By the way, I need to talk about the range. Would be from -1 to +1. So if my autocorrelation coefficient is very close to -1, such as -0.9 and so forth, then we say residuals are strongly negatively correlated. And similarly, if your autocorrelation coefficient is very close to +1, such as 0.85, 0.95, then we say the residuals are strongly positively correlated, or we can say significant positive autocorrelation. So ideally, we want this P2 hat to be 0, actually. It means no relationship at all between the residuals, but it is unlikely to happen to have 0. So if you get something like 0.1, -0.1, something like that, as long as it is very close to 0, then it means good news. The residuals are weakly correlated. Okay, and then I want to talk about the Durban Watson d-test. So if you do this d-test, expect computed d-statistic and critical d-statistic. And the good news is that the computed d-statistic would always be given to you. The reason is that it is very time-consuming to derive the computed d-stat. But for knowledge enrichment purpose, I'm going to explain to you. This is the formula. Okay, so let's look at this hypothetical example. This is the time series regression, expenditure explained by income, 10 observations, and then the information on X and Y. And after I derive the regression parameters, I derive the residuals Y hat. This is how I derive this column. Okay, and then I derive the residuals, which is actual Y minus Y hat. So that explains 30 minus 29 point something, it gives you 0.972. So this is residual at time t, each time period. And then this column, residual lag by one period. So you compare these two columns, I think you can understand this column. Okay, happy with that. And then next one, residual at time t minus residual of the previous period, and you take square. You can't do anything here because for the first time period t equals 1, we don't have the residuals of the previous period. So we can only start completing this column from this point onwards. So this one means 2.972 minus 0.972, it gives you 2. Then 2 square gives you 4. Okay, I'm not going to explain the rest. So I'm doing this part now. And then see the sigma sign, summation. This is why I have to sum all the answers in the column. This is why you get 92.135. Okay, and then for the last column, you simply take the square of each residuals. Okay, and then you sum the answer 63 point something. Then I can also work out the denominator of the computed d-statistic equation, 63 point something. And this is why my computed d-statistic, this is called the official method. It is equal to 1.4595. But as I mentioned earlier, I repeat, due to the time constraint in the test and exam, I would always give you the computed d-stats from this official method. Okay, happy with that? And then actually you have an unofficial, I say we cut corners with valid reason, an unofficial method to calculate the computed d-stat, and this is the formula. Your computed d-stat can be approximated as 2 times 1 minus autocorrelation coefficient. Okay, so from this regression, I really run the regression. Residuals as a function of residual lag by 1 period, and then the autocorrelation coefficient is 0.222, and then using the unofficial method, I derived that my computed d-stat is 1.556, which is actually quite close to the computed d-stat using the official method. Okay, and then look at this table. It just want to show you the relationship between autocorrelation coefficient and the computed d statistics. Okay, so I need to remind you about this unofficial method. So let's look at the first case. This is the ideal case. Autocorrelation coefficient is 0. Okay, if that happens, expect the computed d-stat to be 2. The reason is if you substitute 0 here, autocorrelation coefficient 0. So 2 times 1 minus 0, don't you get computed d-stat of 2? So in other words, when you run a regression, and then remember the e-views table would give you the computed d-stat. If your computed d-stat is quite close to 2, it is actually good news. Then it means the residuals are weakly correlated. And then the next extreme case, if my autocorrelation is exactly +1, meaning the strongest case of positive autocorrelation, then you substitute 1 here. 1 minus 1 gives you 0. 0 times 2 gives you 0. Then it means the computed d-stat would be 0. Okay, and then in the last extreme case, negative autocorrelation, the strongest case of negative autocorrelation, when your autocorrelation coefficient is -1, then you substitute -1 here. Then 1 minus -1 gives you 2. 2 times 2 gives you 4. Then expect computed d-stat would be equal to 4. But this is just the start. We have to officially do the d-test actually. Okay, compare the computed d-stat with critical d-stats. And then for the critical d-stats, there are actually 2 critical d-stats. DL, lower critical d-stats, and DU, upper critical d-stats. And then from the end of the last video, I mentioned that for the d-test alpha is either 1% or 5%. Okay, so let's start with positive autocorrelation. And then this graphical sketch is given in the D table. You will find it somewhere. Yeah, it is here. It helps you to make the decision. Okay. And then the new hypothesis would be insignificant positive autocorrelation. Alternative hypothesis would be significant positive autocorrelation. So what you need to do is, from the D table, you need to look for your DL, DU, 4 minus DU, 4 minus DL, and then you think about the location of the computed d-stat. So if it lies in the rejection region, you reject the null hypothesis, which is bad news. Remember, we don't want to reject the null hypothesis. If your computed d-stat lies here, which means between du and 4 minus du, then good news. It means you don't reject the null hypothesis. But then there's a special case called I am not sure, uncertain, and it is allowed in d-test. If your computed d-stat lies between dl and du, then it falls under the uncertainty case. It means you don't know if the positive autocorrelation is significant or not. Okay. So in order to fully understand this positive autocorrelation d-test, so let's do 3 questions. Okay, let's look at the first one. Multivariate regression, sample size is 10. K prime means, remember K prime stands for the number of parameters excluding the constant, so it is 2 in this question. Alpha is 5%, and as I mentioned, computed d-stat would be given to you 0.575. Okay, null hypothesis, alternative hypothesis, you should be fine. Computed d-stat given. Okay, now we have to look for dl and du, and then the degrees of freedom is actually your K prime. Okay, sample size is 10. Remember, alpha is 5%. Sample size is 10. K prime is 2, then DL should be 0.697. DL is 1.641. Let me enlarge that. Okay. Yes, 0.697, 1.641, and then I can also work out 4 minus DU and 4 minus DL. Okay, and then my computed d-stat 0.575 lies in the rejection region because it is greater than 0 but smaller than DL, 0.697. Then bad news. Then you have to explain, since the computed d-stat lies between 0 and DL, the null hypothesis is rejected. then sorry, H1 will take place, meaning there is significant positive autocorrelation. You can already suspect there is significant positive autocorrelation. Remember from my previous discussion, I said if your computed D statistic is quite close to 0, then it actually means significant positive autocorrelation. Okay, then we can move on to do question 2. Multivariate regression, sample size is 20, K prime is 4 parameters, or 4 parameters excluding the constant, alpha is 5%, computed D stat is given 0.999. You should be fine with this step. You should also be fine with computed D stat. Now we have to look for DL and DU, 20, 4, and 5%. So 20 here, K prime is 4, I am using the right table, 5%. So DL should be 0.894, DU should be 1.828. (0.894, 1.828). Yes. 0.894 DL, DU 1.828, then you can use simple primary school mathematics to work out 4 minus DU and 4 minus DL. But now, since D computed D stat 0.999 is greater than DL but smaller than DU, so it lies in the I don't know regions. So we conclude that we are actually undecided or uncertain if positive autocorrelation is significant or not. Okay, happy with this one? Then we do one last question on positive autocorrelation. This time we use a different alpha, 1%, and I have to move on with the next table actually, which is the next one, when alpha is 1%. Okay, 1%. Okay, 20, n is 20, k prime is 3, computed D stat 0. I think it is a typo error, sorry, it should be 1.734, sorry. So you should be fine with the first step. And you already see the computed D stat 1.734 is quite close to 2, then it already implies the autocorrelation should be quite weak. Remember, we want the computed D stat to be around 2, actually. So computed D stat is given, DL, okay, we have to look for it, 20 and 3. So DL should be 0.774, DU should be 1.410. Okay, and then DL, DU, then you can work out 4 minus DU and 4 minus DL, and then 1.734 computed D stat. This time, good news, it lies in the do not reject H0 region because it is greater than DU but smaller than 4 minus DU. Therefore, good news, null hypothesis is not rejected. Therefore, the null hypothesis will take place, meaning there is insignificant positive autocorrelation. Okay, then let's take a break, and then when we return, we would deal with the other side of D test, which is negative autocorrelation. And then finally, we will look at the remedy, how to get rid of significant autocorrelation by means of GLS, generalized least square.